Okay guys, let us try another parameter here. In our scene here we have this tab which is called particle velocity tab, and this tab is concerned with adding forces to our particle velocities. We can just here manipulate the particle of the fluid simulations as they are fluid, as if they were pop particles. So we can use just particle nodes and the pop nodes that we use in simulating particles here in the simulation of the fluid particles without any problem. So if we just type pop, you have a lot of pop nodes here that manipulate the particles. And if you are doing just a pop network and a particle simulation, all of these nodes can be used here with the fluid simulations as well, because the fluid simulation here, half of the simulation is a particle simulation and half of the simulation is a volume simulation. So Houdini here in the flip techniques simulates the volume simulation and apply it to the particles. Okay, so we can manipulate the particles here, or we can manipulate the volume velocity. Okay, if you don't understand this, this is not important for you. What is just important for you is that you can manipulate the particle velocity. Okay, so if we add this node here which is called pop drag, and this node applies a drag force to slow the velocity of the crashing simulation or of the splashed particles. Okay, so here we have we can add the direction of the point velocity or of the wind velocity, but we will leave this 0 and 0 and 0 because we want just this air resistance which will resist the velocity of the particles as they are splashing away. Okay, so this air resistance, I have done 3 or 4 tests using different values here of the air resistance, but I will stick with the value 0.02, and this will apply a good amount of drag and will slow up my simulation, or slow down my simulation by the amount that I want. Okay, so here are the 4 tests of the drag, and you can apply the value that you like, but I like the value of 0.02. Where is it? 0.02. Okay, global drag. Here is it, 0.04, and this is 0.02, and this one here is 0.03. Okay, so this is 0.03, and this is 0.04, and this is 0.02. So I have stuck to this value, which is 0.02. If you just play here you have 0.04, and you here I think this is 0.05, not 0.04. Yeah, this is 0.05, sorry, and this is 0.04. You see now that our simulation is slower and the particles are dragged in the direction opposite to their force. Okay, so they fly down faster than before, and surely the more values of the if you just increase the value of the velocity of the air resistance to something very high, your simulation will be just shut down, or the particles will not splash at all. So even here the value is just 0.04 and 0.05. The simulation is largely affected by the node. So this is for the global drag. I have stuck to 0.02, and it does a very good job in slowing my simulation down. So this is for this video. Thank you, and I will watch, and you wait for me in the next video.